In 7.3, we're talking about multiplying powers with the same base. As always, please start by writing your learning objective in the slot provided. So today's learning objective is to use and apply exponent rules when multiplying terms with like bases. Let's start with the discovery again to see if we can discover what this rule is. All right, so for those x's, I have x squared, which I'm going to deconstruct into be x times x cubed, which is x times x times x. So to help me discover this rule, I'm going to deconstruct what's written. Okay, and now I'm going to see how many x's am I seeing? Well, x times x times x times x times x is x to the 5th power. Okay, I see 5 of those x's multiplying together. So I want to look at the relationship between 2, 3, and 5. Okay, and let's see what happens with those 5's. So 5 to the 4th would be 5 times 5 times 5 times 5. 5 to the 5, 5 times 5 times 5 times 5 times 5. And now let's count up. How many times is 5 multiplying? Well, I see 9 of them. All right, so now also think about the relationship between the 4 and the 5 that gave us 9, okay? And I'm hoping that you're recalling the rule that when you're multiplying things with like bases, all you're really doing is adding those exponents together, okay? So, key note here is you're talking about same base, okay? So this would not work, okay, because you have a 2 and a 3, okay? So notice here, 2 squared is 4, 3 squared is 9, giving you 36. Like, that's not 2 to the 4 or 9 to the 4 or anything like that, okay? So this only really works when you have a common base, okay? Only that same base. Otherwise, it doesn't work, and you have to just do them separately. So, just to get you to reflect on these rules. So in words, what do? You add exponents. The rule we kind of already took care of up there. Okay, oh, I'm sorry, that's not the complete rule. Complete rule would look like this. Multiplying things with the same base, you add exponents, and I'll leave this to you. I want you to really quickly make another example to show that you understand what this rule is saying. Okay? So, let's take a look at some cautions, some errors to avoid. Okay? First of all, don't actually multiply the bases together. Okay? 4 squared times 4 to the 3rd is 4 to the 5, okay? I can't tell you how many kids I see trying to tell me that that's 16 to the 5, okay? So please, please do not be that kid, okay? The base does not change, okay? The base stays. So it stays 4, you just add the exponents together, all right? Next, don't leave a negative exponent. Okay, so this negative exponent, remember back from that very first day that we had negative exponents, negative attitude, it needs to move. So the 2 is fine, but you need to move down that x to the 3. Okay? And don't add the coefficients. Now, what do I mean by coefficient? I mean that number out front. Okay? That's what I mean by coefficient. Okay? And instead of add, what you really want to do is multiply them like normal. Okay? So here, you want to do 2 times 3 to get 6. x times x to the negative 4. Now here's another good thing to note is anything without an exponent showing is assumed to be 1. Okay, that's another key thing that I'm going to need you to understand to get these. So 1 plus negative 4, or 1 minus 4, will leave me with x to the negative 3. And of course, negative exponent, negative attitude, it needs to move. So now let's go through some various examples of how this can play out, okay? How this is going to work. So number 1, I think is pretty easy. That's the very foundation of what we're doing. M to the 3 times M to the 4. 3 plus 4 gives me 7, okay? T to the negative 5 times T. Well, remember, whenever it's not showing, it's assumed to be 1. So now negative 5 plus 1 is going to give me t to the negative 4. Again, be careful that you know when you're dealing with negatives that you're doing the right thing. So negative 5 plus 1 is negative 4, but we can't leave it like that. Can't leave a negative attitude in the problem. So I'm going to move that down so it can get a better attitude, become a positive exponent. All right, and our next one. So negative 2 gets a first power. The negative 2 to the third, negative 2 to the negative 7. So negative 2, 1 plus 3 is 4, minus 7 is going to be a negative 3. All right, negative exponent is a negative attitude, so I'm going to move that down so it can get a better attitude. Okay, and now because this is numerical, I can actually calculate that. Negative 2 cubed, so negative 2 times negative 2 is a positive 4, times negative 2 again gives me a negative 8. So this is going to be negative 1/8. All right, now let's run through some more examples, okay? Let's just run through how each of these works because each of them have slight nuances that I need you to know. The first one, z to the 8 times z to the 5. Again, that's our very basic rule, right? Just add those exponents together. So I'm hoping everybody gets that one, okay? Now, the next one, okay? So here, remember, one of our cautions we gave you, make sure you multiply any normal numbers that are there, okay? So negative 4 times 6 is negative 24. Now I'm going to add my exponents of k. So negative 3 plus 4 gives me k to the 1. Again, I never actually have to show the 1 though. And again, remember here, a negative number is different than a negative exponent. This is actually just fine as is now. I don't have to do anything else to it, okay? Here, remember, multiply any normal numbers that you have. So 13 times 3 is 39. Now I'm going to add the exponents of x. Negative 8 plus 10 leaves me with 2. Multiply any normal numbers that you have. So negative 2 times 4 gives me a negative 8. And now add the exponents of h. 5 plus negative 3, or 5 minus 3, leaves me with 2. And again, that negative 8 is just fine because that just happens to be a negative number. It is not a negative exponent. So remember, that gets to stay. That's just fine. This one has no numbers out front. So this one, we just get to add up the exponents. 3 plus 6 plus 9 3 plus 6 is 9, plus another 9. So that gives me t to the 18. This next one, multiply the numbers you see out front. Well, this negative is essentially like a -1. So -1 times 4 gives me a -4. Now add the exponents of f. -8 plus 12 leaves me an f to the 4. And again, that -4 is just fine because it is a normal number. It is not a negative exponent. Okay? So, moving right along. This one, there's no numbers out front. Okay? So I just have to deal with the exponents. So this is an m to the first, an m squared, and an m to the first. So 1 plus 2 plus 1 gives me an m to the 4. The ends, I see 2, -4, -1. So 2 minus 4 is -2, minus 1 is a -3. Now, we have a negative exponent, so this is a concern. This one does have a negative attitude. So we are going to have to move that down. So the m to the 4 is just fine, but we need to move the n to the 3 down so it can take a positive exponent. Our next one. Once again, just multiply any normal numbers you have. So 6 times -4 is a -24. Now here, I have a to the 3 times a to the first. 3 plus 1 gives me 4. B to the -2, b to the 8. -2 plus -8, or basically -2 minus 8 more, is a -10. And just to clean this up a little bit now, so the -24 is just fine. Remember, it's a negative number, not a negative exponent. A to the 4 is just fine. But a b to the -10, that has a negative exponent. That's the one with the bad attitude, so it needs to move to get a better one. All right. This next one has no numbers, so I can just start rocking and rolling with my exponents. Q to the 4 times q to the 3. 4 plus 3 gives me 7. For the r's, -5 plus 5 gives me 0. Well, r to the 0, we know, is the same thing as the number 1. So this one actually simplifies to q to the 7 times 1, which would actually just be q to the 7. And our last example in this section, remember, multiply your normal numbers. So -3 times 5 is -15. C to the 7 times c to the -3. 7 minus 3 leaves me with 4. D to the -2, d to the 1. -2 plus 1 leaves me with a -1. So recall the -15 is absolutely fine. C to the 4 is fine. But on the bottom, well, that d has a -1 exponent, so it needs to move down to become d to the 1. Or again, you don't even have to show the first exponent. You could just write it as a d down in that denominator. All right. So moving right along, what does this mean when we're multiplying two numbers in scientific notation? All right, what does this mean for us? Well, what it means is you need to multiply the normal numbers that you see, just like I've been teaching you. All right, so multiply the normal numbers together. So 5 times 1 is 5. And what's my new power of 10? Well, now you add the exponents together. Okay? So exactly the same rules as we've been using, just I wanted to make sure to explicitly show you in terms of scientific notation. All right, next one, exactly the same thing. So 7 times 7, I multiply those together to give me 49 times 10. Well, now 4 minus 5 gives me a negative 1. Okay, so again, you multiply the normal numbers, then you add the exponents. Well, you're probably noticing the same thing I am, or I hope you're noticing the same thing I am, that 49 is not actually in scientific notation, is it? So this, I should really make it 4.9. Okay, remember, it has to be a number between 1 and 10. So I've shifted my decimal 1 over. So I started as a big number. So it's going to contribute to make the exponent on the 10 bigger. So negative 1, and I need to make that 1 bigger. That's just going to be 10 to the 0. And proper scientific notation, even though it seems silly to write it like this, it actually is a legitimate way of writing it, okay? I can leave it as 4.9 times 10 to the 0, all right? So let's talk about a word problem using scientific notation. So the population of a country in 1950 was 6.2 times 10 to the 7. The population in 2030 is projected to be 3.10 to the 2 times the 1950 population. If the project is correct, what will the population of the country be in 2030? So we're starting as 6.2 times 10 to the 7, and it's going to be 3 times 10 to the 2 times larger. Okay, so I'm multiplying that. And they want to know, what is that population going to be? Well, this is exactly what I was asking you to do before. So I need to multiply those main numbers together, the 6.2 and the 3, just like before, to get 18.6. And now 7 and 2 give me a 9. But we need to hold on for a second, because yet again, I'm seeing that this is not between 1 and 10 like I need it to be. It really should be this. Okay? And again, this started as a big number, so it's going to contribute to make the exponent of the 10 bigger by 1, because I had to shift the decimal place by 1. All right. So let's wrap up with a little bit of geometry review. Okay, so we want to write an expression for the area of each figure. Okay, well, first of all, area of a rectangle. We need to remember area of a rectangle is length times width. So I just have to take those two values and multiply them. So 4x squared times that 3x squared plus 2x. I just have to multiply those together. Okay? Well, this is a little bit different than what we were doing before. Okay? Because here, notice, now I have this addition within here. It's not everything just being multiplied. There's some addition within that multiplication. So what I need you to remember is this is going to be our distributive property. Whenever you're multiplying, but there's also addition or subtraction involved within the parenthesis, that is going to be the distributive property. So I need to take this 4x squared and multiply it to the 3x squared. Well, 4 times 3 is 12. X squared times x squared, the 2 plus 2 gives me 4. And I also have to distribute that to the 2x. 4 times 2 gives me 8. X squared times x to the first, 2 plus 1 gives me 3. So these rules of exponents can actually be applied to distributive problems also. Okay? Now, let's look at our final example. So for this one, area of a triangle, hopefully you remember in geometry, area of a triangle is 1/2 times base times height. Okay? So 1/2 times the base times the height. I said that backwards, but again, you know multiplication doesn't matter the order that we do it. We could also do the height times the base, right? This is another distributive property, okay? Notice this subtraction within here. I need to distribute this. So I'm going to take the 5b, distribute it into the 2b squared. 5 times 2 is 10. B to the first times b squared, 1 plus 2 gives me 3. I'm going to distribute this to the 4. 5 times 4 gives me 20, and then there's no other b with the 4, so I just keep the b that I'm starting with. And then, of course, I still have that 1/2 that is out front. So now I'm going to distribute again, okay? I'm going to distribute this 1/2 in. Now this is going to be nice and easy because really it's just dividing by 2. But remember, it's only going to divide that main number, only that coefficient, right? So 1/2 times 10, or 10 divided by 2, gives me 5. 20 divided by 2 leaves me 10. And that is going to be my answer for that one. So once again, thank you for joining me for this. So make sure to take a moment to write that summary. Remember, our objective was to use and apply exponent rules when multiplying terms with like bases. Make sure you write a couple sentences to reflect on that, some of the things that we did, and then make sure you also rate yourself on that scale of 0 to 4. 3 is mastery, where we want you. 1 and 2 means you're on your way. 4 means that you are excelling beyond the scope of the course. So make sure you do that, and then I will see you in class.